The next speaker is Jeremy Eli from Sheffield University in the UK. Over to you, Jeremy.
Okay, thank you. 1 second. Okay, so thank you all for listening today. So I'm going to talk about this project that I've been working on called Deplete and Retreat, the future of Andean water towers. It's a UK government funded project looking at the past, present and future of glaciers and mountains water towers across the Andes. So I want to just highlight that this project is not just me working on my own. There's a big team of scientists from different career stages, nearly 50 different scientists, and some of them situated around the globe, including in the Andes. So we often think about mountains as water towers and the role that glaciers have in these water towers. So they're called water towers by some of the scientific community because they store water on their surface in the form of snow, glacier ice, lakes, and in wetlands, so that water can be later released downstream. And this is really important if you live downstream of a mountain chain because you might rely on the storage in these mountainous water towers for your water resources. So the Andes are some of the most important and vulnerable water towers in the globe, with various high-profile papers, such as these two, with having different assessments of their importance. But the main take-home message is that people rely on the water from these mountains, some of which comes from ever-diminishing sources of glacier ice. So glaciers are really an important component of the mountain water tower system. So by the time you get to a river at the bottom of a mountain chain, your water is going to have been sourced from various different interconnected places. So it comes from precipitation in the form of rain or snowfall, groundwater flow, and elsewhere. And these different sources contribute to that water flow in a variety of ways, storing and releasing water at different times. But glaciers play a really important role at the top of the mountain in regulating some of this flow. So the glaciers at the top tend to store water during cold and wet times and release it when it's much drier and you need the water more downstream. And they also act and interconnect with these other components. They discharge water into the ground water systems, recharging that water, and also feed wetlands and other sources of water downstream. So the mountain system is complex and interconnected, and glaciers have a really important role in that water system. Now we're here to talk about glacier preservation, and I'm interested in the Andes. Well, in some ways, glacier preservation for some parts of the Andes is a bit too late. The last remaining glacier in Venezuela became so small that it was declassified as a glacier. And so now all the glaciers in Venezuela are extinct because of climate change. So we're a bit too late to preserve the glaciers there. But elsewhere in the Andes, the response to humans pumping greenhouse gases into the atmosphere is going to be different. So the Andes is really complex in terms of it has a diverse latitudinal range. It spans a long latitude, which leads to a large range of different types of glaciers and different climates. And the climate across the Andes is changing in different ways, which controls the two main things which determine whether you get how much glacier change you get, which are the amount of precipitation and the temperature in the mountains. So some projections suggest that we're going to get stronger phases of the El Nino Southern Oscillation, which in change the response of glaciers to climate change across the Andes. So the Andes is really a challenge if we want to have skilled projections of what is going to happen in the future and adapt to this more glacier-sparse future and adapt the water systems downstream. Compounding this complexity is a need to monitor our mountains. We have very few observations from high altitudes. And this is bad because mountains are really vulnerable to climate change, and we can't monitor what is going on and validate our climate models so well because we have very few observations. I learned on this project why we don't have so many observations at high altitudes. We installed, for instance, this weather station here at above 5,000 meters, and it's really difficult operating at that altitude. So on Deplete and Retreat, one aim is to try and augment these observations. We've been installing weather stations, like you can see in the top left here, and glacier monitoring equipment, as you can see in the bottom left there, but also looking from space to extend our record of glacier height change, so the glacier geodetic mass balance records, back to the 1970s using declassified imagery. So in the bottom right, we can see a graph here that shows our extended record of glacier change back to the 1970s against a recent compilation of change. And one of the striking things on this figure is that all the numbers are negative, which shows that the mass loss has been going on for decades now, at least. We can go further back in time than that to using geological reconstructions to calculate what has happened since around the 1700s to the mid-1800s, at a time known as the Little Ice Age, when glaciers were a bit more healthy and before the pre-industrial revolution. So we mapped the previous extent of ice in the landscape recorded by the landforms in the landscape and compared it to recent satellite observations. And this really shows that there's been an acceleration of ice loss. So, for example, this plot here shows total glacial area in Cordillera Vilcanota, so that's in Peru, and between around 1650 and the 1980s, there was an area loss of glaciers of around 1 kilometre per year. But since then, since global emissions have accelerated, that has increased fivefold in terms of the rate of glacier area loss. And there's a similar picture across the Andes. The main thrust of our project is to create regionally specific projection of water change, which are useful for people who are trying to manage the water in those areas. So to do that, we are developing higher resolution models that use regional climate models, which are necessary to capture the complexity of mountain climates. That will feed glacier models, which in turn also feed hydrology models. So the aim of the project is to get a long-term perspective at regional scales, looking back to 1850 and projecting change forward to 2150. So this work is ongoing, so watch this space, but we hope to have results from this modelling by the end of the year. And we're also interested in what's going to happen as we get more and more extreme events and what happens to water resources during those extreme events. So under climate change, we're expecting more extreme climatological and meteorological events to be more commonplace. So we've been modelling specific events with our high-resolution climate model, such as the 2023 winter heat wave. That's been feeding our glacier models, which in turn feed our water models. So essentially, we want to look at how much does glacier melt during a heat wave produce extra water to maybe prevent or offset slightly drought, and how much longer can glaciers do that until they're all gone or diminished in their capacity to do so. And then the final thing we're interested in for the Andes specifically is what happens when glaciers are much diminished and go. So I think from the previous talk, you can tell we're doing a pretty bad job at preserving glaciers. And once they've vanished from a landscape, in high altitudes, such as in the Andes, then the wetlands in the Andes called bofedales become more important in this glacier sparse future. So these kind of spongy landscapes you see here store some of the water and discharge it downstream and somewhat offset the glacier loss. But these obviously have very different dynamics to glaciers, and so their role is becoming more important, but they're kind of understudied phenomena. So just to finish my talk, so a bit of a summary and a pretty grim outlook, I'm afraid. So it's quite clear that glaciers are becoming more endangered across the Andes and indeed the world, with rates of ice loss accelerating since the Industrial Revolution. So, you know, perhaps glaciers should be considered in a similar way to how we consider the tiger, pandas and rhinos as endangered species. Perhaps these landscapes are endangered landscapes. And before glaciers go the way of the dodo, we really need to start planning for that much reduced glacial future. And the reason for that is that the loss of water resources in these regions and glacier resources will really threaten the ecosystems and the people that rely on these glaciers and will have large geopolitical ramifications. So thank you for listening to my talk today.
Thank you very much, Jeremy. I can relate to the difficulties of obtaining high elevation data, good quality data from the work that our group here, led by Doug Hardy, has been carrying out in Peru and on Kilimanjaro and Tanzania. It's very difficult to get good data. So thank you for that perspective. And our next speaker